Lesson 9.3, Transformations. Our essential question is, what effects do transformations have on quadratic equations? The transformations that we're focused on are translations, dilations, and reflections. So these are all types of transformations. And a transformation is a change. When something transforms, it changes in some way. So the changes that we're going to be looking at, a translation is sometimes referred to as a slide. So it's when you take a figure and you slide it to a new location. It may slide to the left, to the right, up or down, or some combination of those things. It does not change in size or shape, though. So I'm going to say preserves size and shape of the figure. The next one that we're looking at is a dilation. A dilation is a change in size. But not shape. A dilation is when you make a copy of something, but it's like a larger scaled copy or a smaller copy of a figure. And then the last one is a reflection. A reflection is a flip. And that one preserves size and shape, just like a translation does. Okay, so let's start analyzing these quadratics. So on a graphing calculator, I would like you to graph these three quadratics. And what we're looking for is we're looking to compare the second and third quadratic with the first one. So the parent function is y equals x squared. That's the most basic quadratic. So it doesn't have any extra numbers in it at all. The parent function, y equals x squared. If I graph it, it has a vertex at 0, 0. It has ordered pairs at 1, 1 and negative 1, 1. And then 2, 4 and negative 2, 4. So it is a parabola with axis of symmetry being the y-axis. So what happens if you graph these on a graphing calculator? What happens if you have added 3 to your x squared? Adding the 3 right here, you should see, slides your quadratic up 3. So it's a translation, up 3. So I take my vertex, slide it up 3, take the other points, slide them up 3, and graph my new quadratic. It's the same size and shape as the original quadratic. You just slide it up 3. The next one, similarly, the minus 4 slides it down 4. So this is a translation, down 4. So take my vertex, slide it down 4. Take my other coordinates, slide them down 4. Draw my graph. So it's the same size, same shape, just down 4 from the original. So these are translations where you're sliding up or down. So I want you to notice that the x squared stayed exactly the way it was, and then there was either 3 added or a -4 added. The order, remember the order when you're adding doesn't matter. So for example, this bottom quadratic could look like this, -4 plus our x squared. And that would mean the same thing. That would still be a translation down 4. So if you're adding or subtracting a number to that x squared, it's going to be a translation up or down. The difference on this next slide, now we have a change in the parentheses. So we have the same parent function, but then we're changing where the x is in parentheses, so the x squared part is changing. This is going to cause a different kind of a shift. So the original quadratic stays right where it was. So here's my parent function. Now, this change in the parentheses gives us a translation again, but it doesn't slide up 2, it actually slides to the left 2. So something for you to think about, on the up and down translations, they slid in the direction that we would expect. The plus slid up, which is the positive direction for the y-axis. The minus slid down. Now that's not happening. That's not happening. When you make the change inside the parentheses here, the +2 goes to the left, which typically you would think is the negative direction. So to the left 2, here's what it looks like. It's easier to see on this one that they are the same size and same shape, because it's misleading when you slide a quadratic up or down. It's misleading how large it looks. So this one is a little bit better that way. So the -5 in parentheses is a translation again. And you should see on your calculator that this one goes to the right 5. So same size and shape again, but to the right 5. All right, the next 3, same parent function. And now we're changing and we're multiplying something instead of adding or subtracting. So we're looking at the effects of multiplying on a quadratic. So the first one we are multiplying by 3. So 3x squared, where you should see this quadratic is, same vertex, but instead of 1, 1, it's 1, 3, like this. And if you put in 2, 2 squared is 4 times 3 is 12, that'll be way up here. So this is a very skinny quadratic. I don't have to make it go up to 12. You get the idea if I leave it here. So it is skinnier. It is skinnier. What that is called is a dilation. A dilation is when you change the size. Now this dilation, because it's getting skinnier, is called stretched vertically. Because if you stretch something vertically, it's going to get skinnier. Stretch it out vertically, like pulling on it and pulling it up. The next one with the 1/2 is going to have the same vertex, but 1/2, if I put in 1, I'm going to get 1/2, so underneath here. And if I put in 2, 2 squared is 4, half of 4 is 2. So 2 is out here. So this one is going to be wider than the others. This is called a dilation, and instead of being stretched, it's called compressed vertically. If you press down on something, think about pressing down on the top of something, it's going to make it wider. You press down on it, so compressed vertically. Now our last change, we've got the same parent function, y equals x squared. And the only change on this one is the negative sign in front. What that negative sign does is flips it upside down. Remember, we talked about how A controls whether your quadratic opens up or opens down. If A is a negative number, your quadratic is going to open upside down. So this is a reflection over the x-axis. Okay, now comes the tricky part. We are going to put together all of these changes, and we are going to figure out what kind of transformations have occurred. And what's tricky is that we're not looking at just one at a time. Looking at one at a time helped us determine the effect of the different numbers, the different changes. When they're all put together and you graph two quadratics, like if you graph this one with the parent function, you might not be able to pick out all of the things that have happened. It might be overwhelming. So we're going to look at the 5 and the 4 separately. The 5 out in front is going to dilate it, so it will be a dilation. And because that number out in front has an absolute value greater than 1, absolute value greater than 1. The absolute value of 5 is 5. So that's greater than 1. That means it's going to be stretched. If it was less than 1, it would be compressed. So stretched vertically. And then the 4 is a translation. And it's the one in the parentheses, so the plus 4 actually goes to the left 4. So 2 changes on that one. The next one, 2 changes again. It's going to be a dilation, but because the number that's being multiplied is less than 1, the absolute value is less than 1, it's a dilation compressed vertically. And then translation, and it's a plus 2, and it's not in parentheses being squared, so it's up 2. So 2 changes on this one as well. Our last 2 have more changes happening. This is the hardest one, I would say, when there's this many changes. So starting with the negative sign, not the 3. The negative sign is a reflection over the x-axis. Then the 3 is a dilation. So that negative 3 represents 2 different transformations. Dilation, and that will be stretched vertically because the absolute value is greater than 1. Then we can move over to the 2, and this is going to be a translation. And the plus 2 in the parentheses goes in the negative direction, so left 2. And because it's a translation for the 1 here, I can just say and up 1. So I don't have to write the word translation twice. All right, last one. Negative sign is a reflection again over the x-axis. Okay, the 2/3. The 2/3 has an absolute value less than 1. So dilation, compressed vertically. And then our translation this time is going 2 directions. In the parentheses, the -1 is right 1, the opposite of what we would expect. The -7 is down 7. Done. Okay, you should be able to write a summary now, answering your essential question and talking about the effects that you have comparing the equations to the graphs of quadratics.